All right, part B, adding and subtracting rational expressions. Yay! All right, steps to simplify. So 1, we're going to factor the denominators. 2, we're going to find the LCD. Okay. 3, we're going to multiply each term to get denominator equal to the LCD. Then remember, what you do to the top, to the bottom, you do to the top of your rational. And then 4, we're going to add and subtract and combine like terms and all that fun stuff. And then 5, we're going to simplify more if possible. Then 6, simplify each sum or difference even more if necessary. And then 7, we're going to state any restrictions on the variables. Okay, that is our plan of action. Okay, so add or subtract, simplify where possible. So looking at our first example, we have x plus 2 divided by x minus 1 plus x minus 3 divided by 2x plus 1. So step 1 says to factor. Well, our denominators. When we look at our denominators, they are factored. So step 1 is good to go. Denominators are factored. Okay. Step 2 says to find our LCD. So because they're factored, our LCD equals x minus 1 and 2x plus 1, right? They're missing each other. Step 3 says we're going to multiply each term to get the denominator equal to the LCD. That goes back to when we were talking about LCD and LCM. That means if I was to divide the denominator by if I was to divide the LCD by my denominator, what factors are missing? Well, what would my quotient be? So what factors are missing is what we're trying to figure out. So looking at this denominator and this LCD, well, I already have x minus 1. What factor am I missing? I'm missing 2x plus 1. So if I was to divide x minus 1 times 2x plus 1 by x minus 1, my quotient would be 2x plus 1. Okay, so we would have to do x minus 1 times 2x plus 1. Well, what I do to the denominator, what I do to the bottom, I have to do to the top. So I'm also going to have to multiply the top times 2x plus 1. Plus, and I'm going to do the same thing with the other denominator. So 2x plus 1, got it. What is 2x plus 1 missing? X minus 1. So we have 2x plus 1. It's missing x minus 1. What I do to the bottom, I have to do to the top. So we already had x minus 3. I have to multiply by x minus 1. So let's highlight what we did to each one and change. So in the first rational expression, we multiply numerator and denominator by 2x plus 1. And the second rational expression, we multiply numerator and denominator by x minus 1. Okay? And now we're going to add, subtract, combine like terms, all that fun stuff. So we're going to just start multiplying and simplifying. So that's what steps 4 through 6 are, handling your business. So when I multiply here, I'm going to combine. So I have to FOIL. So I'm going to FOIL to combine. Okay, so again, we're foiling, and we're going to also FOIL here. And we're combining through addition, so we won't have to worry about any parentheses. So we have 2x squared plus x plus 4x plus 2 plus, so that's our first plus, FOIL again. So we have x squared minus x minus 3x plus 3 all over, and we want to keep our LCD in factor. So we're going to keep our denominator factored. 2x plus 1, x minus 1. All right, now I'm going to keep simplifying, combine, add, all this good stuff. So I have 2x squared and 1x squared here. So we have 2x squared and 1x squared. We have x, 1x, 4x, x, negative 3x. And then we have 2 and 3. So we're going to go ahead and combine all like terms. So 2x squared and 1x squared gives me 3x squared. 1x plus 4x is 5x, minus 1x is 4x, minus 3x is 1x. And then we have 2 and 3, which make 5. All over 2x plus 1 times x minus 1. All right. So we are down to here. We have 3x squared plus x plus 5. And we can try to factor this really quick, but think about this. If we were to, this is a complex trinomial, so that should make us think of x. And so a times c is 15, and my b is 1. Are there two factors that multiply to give me 5, but add to give me 1? And the answer is no. So this is not going to be something that is factorable. So we don't have to go any further. We stop here, and this would be our most simplified answer. Okay, so the reason why we want to leave the denominator untouched is so that we can state our restrictions. So I have 2x plus 1 and x minus 1. This is my solution, well, my simplified expression, but x cannot equal negative 1/2 and x cannot equal 1, because if they did, then they would make my denominator equal to 0, and it's a no-go for 0 in the denominator, okay? There we go. All right, so let's do this again. So step 1, factor the denominator. So factoring my denominator, I have, this is x minus 1, and x, right? Good to go. Check. Step 2 is to find your LCD. So my least common denominator. So basically looking at my factors, what are the greatest powers that they have? So x is greatest of that factor, and x minus 1 is the greatest of that factor. So that's my LCD. Step 3 is to multiply my expressions by the factors of the LCD that they're missing, essentially, right? So the factors of the LCD that they're missing. So if I look here, this one is not missing any factor for my LCD, so it's going to stay itself. I'm going to move it over here so there's some room. So it's still going to be x over x times x minus 1. This one, the factor of the LCD that it's missing is x minus 1. So I'm going to multiply the numerator and denominator by x minus 1. So now I'm left with plus, and I have x minus 1 over x times x minus 1. Okay? Remember, when you're adding and subtracting, you do not combine the, you do not go x times x or x plus x. There, your job is done. So now you're going to focus on solving. So 4 through 6, I'm going to add. So I have x plus x minus 1. So we have x plus x minus 1 over my LCD. This equals 2x minus 1 over x times x minus 1. So 4 through 6 is done. Check. And then 7 is, what are my restrictions? So my restriction is x cannot equal 0 and x cannot equal 1. Because if I have 0 or 1, then this will not be defined. And there we have it. All right, so thing number 1, remember, every number can be written as a fraction. Just put it over 1, right? All right, so factoring, I have y squared plus 3y. Because it's over 1, is it really completely necessary to factor? Probably not, but it's good practice to factor. So we're going to factor. So step 1, factor. So we have y times y plus 3. GCF, little GCF factor here and there. Doesn't hurt anybody. So we factored. Step 2 is to find our LCD. Well, it's between 1 and that. So our LCD is y times y plus 3. Okay. Then step 3 is to multiply our denominators and therefore also the numerators of those denominators by what's missing from the LCD. It's only our first term here that's missing, our LCD. So it becomes 4y over y times y plus 3. Now notice if I multiply the denominator, I have to also multiply the numerator. So 4y times y plus 3 minus y plus 2 over y times y plus 3. Okay, boom. All right, now subtraction you have to be very careful with when you start simplifying. The minus does not just apply to the first term, it applies to the terms that follow, all the terms within that factor that follows. So for parts 4, so I end up with 4y squared times y plus 3 minus, and it's not just minus y, it's minus y and minus 2. So minus y minus 2. I'm going to go ahead and keep cleaning this up because I know that my denominator is going to be this. So I'm going to go through and get it together. So I have 4y squared times y plus 3. So I'm going to distribute. That gives me 4y cubed plus 12y squared minus y minus 2 all over y times y plus 3. Okay. And I'm going to keep simplifying because that's all it says, simplify more if possible. Simplify each sum or difference. So you just keep simplifying. So now I look and I'm like, well, is there any more simplifying I can really do? Nope, cannot. So 5 through 6 is done. Now I'm at 7, and 7 is stating my restrictions. So what are my restrictions? Well, y cannot equal 0, and y cannot equal -3, because if they did, then they would make my denominator equal to 0, and it is a no-go for 0 in the denominator. Okay, and there we have it. So things to note when subtracting is to make sure that you distribute your minus to all terms in the factor that follows it. Okay, so you want to make sure you distribute the minus into all terms of the factor that follows it. All right, adding and subtracting.